Hello everyone, welcome to the community updates of Electronics Let's Play. As I described last stream, we wanted to make this a more official segment of these streams, as there is always a lot of interesting stuff happening in the community in and around 1Bit² and the things I'm working on, as well as the people are working on Twitter with FPGAs, ASICs, electronics, all the interesting stuff that we are fascinated with around here. So this week, for the first time, I asked also the community to submit their information that they wanted to share on this segment. And I would like to start, as we did last time, with a few updates from my end, what I was up to. And the first thing is my endeavors into ham radio. I ordered a bunch of cables, coax, antenna connector crimpers. I also got the Nano VNA, which we might take a look at here on the stream. And I decided to actually not buy a ready radio, like a fully assembled one, but I will go with this thing. And this is an MCHF, which is designed by M0NKA. And they created this really awesome radio, which has schematics published. The complete firmware is open source under GPL. And this will be a kit that I will order. So the information to me was that they will be available on the 10th. So I will place an order for a kit and we will assemble them here on stream. I think it will be its own section. So because I probably want to get it done pretty quickly, I might actually stream a few days in a row to actually work on this and put it all together. Main part will be actually winding the magnetics for it, and the SMD part is already pre-assembled, which is somewhat of a bummer, somewhat a good thing, because we will get a working radio quicker. But yeah, this is a project we will be working on, and I have this is in progress and is prepared. Yeah, this is how this looks, fully in its case. And this is the motherboard, and I will definitely show all of this, and we will be winding all these magnetics here. This will be fun. Oh, wow, this looks different than in one of the tutorial videos I watched, but yeah, that's very nice. I hope you are excited as much as I am to play around with ham radio a little bit. Next thing is Icebreaker Bitsy that we worked on here on stream. I thought this will last longer, but it turns out yesterday already all of the ones that I put in the store. So I had 9 units of the Bitsys assembled. Some of them went to developers and I had a few extra, so I thought maybe make them available for the community. So I put them on the store and all the remaining units just disappeared yesterday. So that's very cool. It's very exciting. But don't worry, Jordi is working already on the next revision of the board. It's almost done. And the main difference is the programming connector. So this is this section here on the right. Wow, I should probably... Can I... This is difficult to zoom in because my views are here over this. But anyways, this is allowing us to access the programming connector on the right side, also from the top side. This means we will be switching over to a flash chip that is in a smaller package. And we did double and triple check that this actually exists, because there were TNT brought up a very good point that this might not exist because the die size is the limiting factor. So sometimes you can't fit actually the flash in the smaller packages. But yeah, we checked it and this should be available. Meaning even if it is in a circuit, we will be able to, or like plugged in into a board, we will be able to program it. This is the back side. So just this is pretty much the main difference here, this programming connector. So I'm looking forward to what Jordi will come up with, and we will be definitely keeping you up to date how things go. And as soon as I have the next prototype run, I will also make a few extra. So you might be able to get your hands on some early prototypes, which might be somewhat of a collector's item for some. I know this is for an orange grab thing people are doing. Ah, you haven't committed it. Okay, so Jordi has already finished routing this. That's very exciting. I'm looking forward to that. Next thing is TieGuard. TieGuard is a project spearheaded by Joe Fitz for his classes, and this site is now official, so check it out. Subscribe as soon as this campaign goes live. This will be a very interesting board for hardware hacking, interfacing with hardware, programming, UART, JTAG, SPI flash, all the things. So this will be very interesting board, and you should check it out. That is still in progress. Next is a submission from Hackaday or Sophie Kravitz. Sophie Kravitz is also had a submission, which is very interesting. Hackaday is organizing a remote workshop and remote con, essentially. So as you know, I am a big fan of SuperCon Hackaday conference, which is a really great event. And because of the situation currently, Hackaday decided to not do it in person, which is pretty much the standard these days. And they are looking for submissions. So this Hackaday Remote Con submission page is now live today, and I encourage you to submit workshops. So I will also post the link here in the chat, just in case, so that you can take a look at it. Yes, definitely. And I'm sure there will be, or is already, a talk submission ready. I'm not 100% sure. I should have pulled it up. But if it is happening a little bit later or at the same time, I will definitely let you know in the next community update. So Sophie, if you are watching this and you want to submit a different link for not workshops, but for talks, then please do. And I'm sure we will have a really great event with a lot of good submissions there. Next is Ed Borden. Oh, wow, why is it reloading? There we go. So you might know Ed from the Discord. He is doing an amazing job maintaining and designing and expanding the nightly build system for the open source FPGA tools. So this is this project here on GitHub, which is the Open Toolforge FPGA toolchain, where you can download pre-built, statically linked binaries for pretty much the full set of tools you need for building FPGA bit streams for those chips that are supported by the open source tools, aka Lattice ICE40, Lattice ECP5, as well as some others. This is a different project because this is specifically just the binaries that you need. So it is not not trying to be like a machine that does everything. It is actually taking the tools that are known to work well, are known to be stable, and we just wanted to keep it easier to have the nightly builds because everything is still moving forward quite fast. So this is just the C, C++ binaries, aka Yosys, NextPNR, IceProg, or IceStorm tools, Project Trellis. These tools compiled as a statically linked binary for Windows, macOS, Linux, so that you just take this tarball, download it, put it in your home directory, unpack it, send your path, so binary path, set it to that directory, and you're good. So you can all use the Verilog flow. I think we also now have, or added also support for VHDL, so that should be working too now. So I was using it for the several last weeks, like more than a month, and it is he keeps adding additional tools. It's very nice. It works very well. It did save me a lot of time. Oh, there we go. There is a complete list of the binaries included, which is very, very nice. And I used it for several projects, and I think this is a good solution, unless you need something very specific like I think the GUI so the UI, graphical UI for Next PNR that shows you live how things are being placed is not compiled in because of Qt5 linking issues. But this is quite a niche thing to need. It's more of like an eye candy thing. So I don't think this is a huge problem. And in cases you really need that, you can build it yourself, or there are some other distributions that might contain it. So that said, like explaining what that project is, Ed was asking what should be the next thing to add. And he had a poll, so definitely follow him on Twitter because there will be more polls like this. And he asked what we should add, and essentially we want symbiosis. So basically the ability to do formal verification flow for FPGA so that we can actually formally verify our Verilog or GHDL. And yeah, that's good. The community spoke, and he will be adding that. But we see that the interest is also there for the iVerilog simulation, as well as ARM builds to be able to run the toolchain on Raspberry Pi. So I'm sure these will come eventually too, but this is more of a direction which things should be worked on first. We also are working on people are starting to contribute to the project, so we might also get the similar binary build for the tools necessary for ASIC synthesis. So look out for that. So definitely follow that project. Follow Ed. I'm sure he will be making announcements here, and as well as on our Discord in the Open Tool Forge channel if you have any questions. All right, so next thing is Dave Berkeley on Twitter. He posted this very interesting thing. So he is designing an audio DSP running on Icebreaker FPGA using the RISC-V Serve soft CPU, which is this serial binary, I think, implementation from Olof Kindgren. And Olof designed the Serve, and Dave is using that core together with peripherals to create a DSP with 8 channels. And yeah, it's a very interesting thing. There is not much audio stuff I've seen happening recently, so I'm always excited to see projects related to the Icebreaker that are working on some audio related stuff. So this will be, I think his main goal is to do phase array audio related stuff. That's something for Jared, I think. He might be interested in that. And this is the goal of this project, and he will be using this design of DSP to implement these things. So I am looking forward to what will come out of this. Based on that, he was asked if he's publishing any of the designs, and he is, and he published the DSP, but he also published his version of the Serve RISC-V CPU with additional peripherals, so his SOC version of this, and you can find it on his GitHub. So definitely give Dave also a follow and check it out. Hi Hi, Unexpected Maker. Thank you for joining the stream. I appreciate it. I'm sorry. I'm trying to get the community updates as soon all out and in order. So yeah, there you go. Yeah, I will. The link for maybe. That's a good question, Jordy. Let me drop the link here. I will try my best to also post these. No, that's wrong. I copied the wrong thing. Just a second, I will do that. Control, there we go. That's the correct link. That is his GitHub. I think that's the best thing to do. I will try to also for this segment take these links and add them below the archives so that you will be able to find them after this is archived with all the links to that. Yeah, there's a lot of news to share. So yeah. Next thing is Valentin, which he got elected to be the RISC-V Board of Director Community Outreach. And this was an announcement only yesterday, which is very exciting. So there, if you have anything related to community for RISC-V SOC, you should definitely check him out and follow him on Twitter. And what made me very happy personally is he is a professor at the formerly FH Munich and now the Hochschule Munich, which is I almost ended up studying there way back when. I didn't end up there at the end, but that's basically, oh, he's from my old corners. So that was very exciting when I found that out. But that said, we have a new community outreach person for the RISC-V board. So that's very exciting. Next is Matt Venn. And why did I... This was not exactly how I wanted to open this. I should have checked. So Matt said, there we go. That's the correct post. So he has some additional documentation for his ECP5 basic board. So he designed this FPGA board, which is this one. This board is a reference design for ECP5. It is not meant to be a commercial product. At least that's after Drew Fustini asked him if he's planning to make it into a product. He said, I don't have time for support or making this into a product. His main goal is to make it as accessible and documented well enough for people to use this as a reference design for ECP5 things. So this is Matt Venn's publication here. So I will post that here too. And let's see, he also posted, he has a VGA clock. Oh, this is also very interesting. So I mentioned that I think last week, he designed this HDL, which implements a clock that is being shown on a VGA monitor. And this design is synthesizable for an FPGA as well as for an ASIC. So this is the interesting thing. So it also has a full simulation, and it has statistics here about the results when you synthesize it for an ASIC flow. So that's a very interesting exercise here, and you should give it a look if you are interested in the newly more accessible ASIC-related designs. So there you go. Okay, what else? Last but not least is Rachel, who is also here. Hey, thanks, Mon. She designed a PCB. Oh wait, I am again. Ah, there we go. So this is a mechanical keyboard that she designed, and it is the main difference from other mechanical keyboards is using a dedicated driver chip for the RGB LEDs to get really high refresh rate ability. So essentially, the problem with RGB in keyboards usually is that the refresh rate of those LEDs is not very fast. So you get a lot of flicker. If you're sensitive to flicker, and some people are more sensitive than others, you, especially in your peripheral vision, if you have any RGB stuff on your keyboard and it is not a high frequency PWM keyboard, then you will get distracted by it and you will probably not use it or want to have it on. If you still want RGB, you would want something that uses, for example, ATA 102 LEDs or something related similar. But in this case, she designed dedicated drivers, or get splitting headaches. Yeah, exactly. If you have flicker-induced migraines and stuff like that, this is a very important thing. So these driver chips are special driver chips that drive each LED separately with PWM. They have high frequency, I think you said 4 kilohertz PWM, which is pretty high and good. And thus, this is a specific design for this. And she's also streaming on Twitch. And so last Saturday, I had her stream open in the background, which was very cool. And I watched her rework the boards, and it was very, very cool. Definitely give her a follow here on Twitch if you are interested in some electronic soldering as well as C++ development. I hear she's also working on the firmware for this in C++ for the whole board. So this will be a very interesting stream. So yeah, that is, I think, everything for community updates for today. You're welcome, no problem. And these community updates will keep coming. And next week I will do this again. And I hope that I can put together a good platform for people to share their projects that they're working on. Oh yeah, and I should get to the rest of my list that I didn't open. There you go. So we have also Glasgow that I skipped, and I'm really sorry about that. Thank you for reminding me. So Glasgow we still are making some changes to the hardware. So essentially what happened is I went on a little bit of a redesign of the board to improve manufacturability for this. You saw that on the previous streams, and then Electronic EO also dove in and made some changes. I told you last week we had especially the ADCs and the addition of current sensing was added. What we still wanted to do is figure out if we want to change the main power capacitor here. So it turns out this footprint is not very commonly available. I mentioned that also on last stream, that it was a little bit of a pain to find this exact foil capacitor for this footprint. And so Electronic EO mentioned that there's a slightly bigger footprint that we should put in here. And we will do that. I decided not to do it on stream because it is fairly boring. We will change this footprint. The second thing is White Quark had a brainstorm in the channel for Glasgow and asked if it would be a good idea to add a dedicated button for reset. So not exactly reset, it is break glass in an emergency type of button. We will probably add that. This button will essentially have the same function as Glasgow Safe. Glasgow Safe command disables power supply and disables driving of the GPIO on the whole Glasgow. It is a command that requires synthesis. It's not something at the moment, the way it is designed, that you would that you want to use it very, very often, unfortunately. So it is not essentially you want to use it. It's like you connect it to a device. you realize it is heating up quickly, instead of running, like unplugging it from the USB or like ripping out the cables, you can press the button and put it in a safe mode. That is essentially the idea. No, revision D is completely separate topic. Just to clarify how the versioning works on Glasgow, the A, B, C, D, E, F, G are parallel designs. They will always exist in parallel, and they will be always supported and be developed further. They are separate hardware from each other. So a revision C is the first stable one. D will be a different design living next to this one that will have 32-bit GPIO instead of 16, and might use different parts. E revision will have ECP5 and be again another separate silo of a design that will be not replacing the previous versions, but living next to each other. The number is the revision number. So this is revision number 2. And this is where we keep upgrading and finessing that specific design trench. And so, yes, it should be type C or type D, type E. This probably would be a more clear distinction. Yeah, hardware configuration, yes. I think that would be more clear Jordi, that's a very good description. It is more of a Raspberry Pi A, B, B plus version, and then the number is the actual version number. This is actually a good point. We might want to bring this up to clarify this and make it a little bit more intuitive in the future. This is good input. I will talk to Whitequark about this. We should. So it is the family. This is the C hardware type, and then D will be another hardware type. So yeah. Yeah, Model C revision 2, yes. Yeah, so this is the status. We need to make these two small changes, and then I hopefully can finally order the prototype boards. So that was the showstopper why I didn't order the prototypes. And when we get that, I want to have the prototypes here so that I can make proper photos for the campaign page. So that is my showstopper on the campaign, is to have the correct photos for the campaign of the revision here, so that we speak about the correct hardware, because we also made some feature additions which were not available in the revision C1, which are not, so essentially it is backwards compatible completely and adds the current measurement on the supplies, which is very useful for safety reasons as when we are using these. Yes, so I think we will have to broach that topic again and talk about the naming. All right, so I hope that answers your question about what the status is of Glasgow. This is the status of it. And yeah, if that would be it, if there's no additional comments, then I will wrap up this segment. And I will see you all next week at the same time. And I will try to share as much of information from the community and interesting projects as I can, and keep you up to date on projects like this too. So yeah, again, thank you for supporting these, and thank you very much to the Patreons, and thank you very much to everyone here in the chat commenting and being part of this. And I see you next week. Bye.